Welcome to a Phoenix Consultancy webinar on root cause analysis.
So we're going to talk about root cause analysis. The aims of the short webinar are to define root cause analysis, determine the areas when it's going to be useful to you, outline how it should be performed, describe some key tools and how to use them, and then discuss next steps once you've completed your root cause analysis, and some other uses for the tools that are present within root cause analysis toolkit, because they're not useful just for root cause analysis. If we're defining root cause analysis, it really is something that the name is on the tin. It's a systematic method of problem solving aiming to identify the root causes of a fault or problem. A root cause is the cause which, if removed from the chain of events, prevents the problem recurring. It's got to be distinguished from other causal factors in the sequence of events which are important in the causation, but actually are not the root cause. So if we look at this example, here we've got an equipment failure because it overheats, because it's got a low coolant. And the root cause was a coolant leak. It'd be quite possible to detect a low coolant level and to top the coolant up and temporarily solve the problem of the equipment overheating and failing, but it wouldn't permanently resolve the situation if the coolant continues to leak. You could even move further back in the chain to say, well, why is the coolant leaking? Is it a result of poor maintenance of the equipment or poor manufacture? So what's root cause analysis going to be useful for? Well, its biggest use in the NHS is probably for incident investigation currently. That's incident reporting, non-conformance investigation, and particularly in infection control, looking at cases of MRSA, C. diff, etc. But we're talking about it here in the context of quality improvement, because root cause analysis is an essential component of the PDCA cycle in A3 thinking. But why is it useful? Well, it's because it helps to find ways to stop the problem recurring, as I said earlier. We want to try and solve these problems permanently if we can. Also because when it's properly conducted, it engages everyone in trying to solve the problem rather than using knee-jerk reactions and playing the blame game. And if you do that properly, you can avoid unnecessary conflict about who's to blame for the fact that there's no grass. It also avoids rubber stamping the wrong solution. It's very easy to jump to a conclusion and then just find the evidence to support your conclusion without looking systematically at why the problem started in the first place and what the actual root cause was, so that you can permanently eradicate it. So what we're going to need for an effective root cause analysis, the most important thing is to find some dedicated time and space for the key staff involved and actually free them up so they can come to the area. And you really want people who've studied the Gemba. They've actually gathered the data from the areas and they know where the work is being done intimately. The resources required are really quite simple. Flip charts, whiteboards, pens and paper, post-it notes are required. You can get tools for Excel, and at the end of the webinar what I'll do is I'll put together a PDF and give you some websites where you can download Excel tools for some of the root cause analysis Excel add-ons. I think the most important thing, apart from the above, that is time and space, is having somebody who's going to act as a skilled facilitator. That's really where you're going to come in bringing the team together to address the problem and asking the right questions. It's also important that the facilitator puts together a structured agenda. It's often useful if, as well as having the facilitator, there's somebody else who can write down the notes, so the facilitator can actually concentrate on the group that are working on the problem. So when you're facilitating, it's useful to have an agenda. I don't necessarily myself think you need to circulate an agreed agenda, but I think if you're facilitating, you need to have a very clear idea about how you're going to structure the session and work through things step by step to make sure that you don't forget something. The first thing you need to do is to emphasize that the goal is to find out what the root cause of the problem is so that we can actually stop it recurring, and not to apportion blame to anyone. It's all about why the problem occurred rather than who caused it. The other thing for facilitator is try and ensure that everyone's voice is heard and that all points of view are heard, because there's a huge value in trying to leverage diversity when you're problem solving. And the reason for that, I think, is that we all come at problems from different points of view because we've got different experiences, different views of the Gemba, if you like, and we've got different specializations. So everyone will have a point of view that will shed some new light on the problem or bring some data to the meeting. So it's important to make sure everyone's voice is heard. And generally, I'd introduce everybody at the meeting or get them to introduce themselves and then give an overview of the process that's to be followed if I didn't have a structured agenda for everyone, really going through step by step what we're going to do. Talk about the problem statement, summarize what is known about the current state, the goals and the waste in the process. And if you're doing an A3, there should already be a high degree of consensus about the problem statement and the current state and the goals before you get to root cause analysis. However, when you're doing the root cause analysis, it may cause you to actually go back and think again about your problem statements and certainly think that there may be some facts and data in the current state that you haven't got in order to do a proper analysis of what the root cause is. And then you'd probably choose to use some simple tools. You might use a checklist, fishbone diagram, 5 whys, and Pareto, and I'll talk about those a little later. And then it's important at the end to try and summarize the conclusions of the meeting and write it up so that it can be used in the next stages of the A3. We've got some tools, and I've summarized those previously. This is an attempt on my part to say that the tools are important, but you've really got to consider, are they the right tools for the job? And get away from the problem that sometimes when you're holding a hammer, every problem's a nail, and actually you need a different tool for a different situation. So it's really important to ask the right questions and use the right tools. The meeting is going to do some brainstorming, and I think a lot of attempts at brainstorming are flawed because they don't have a structure. And there's quite a lot of research now on what is the most effective way to brainstorm and leverage that diversity I spoke about earlier. The first thing is to have absolute clarity about why people are there. Explain the purpose and the methodology, put people at ease, and really get feedback that people are at ease and understanding what we're trying to work on. To clearly set out the problem and the goals. And then give people time to think individually, whichever of the tools you're using, and write down their ideas, and then bring the group together to work on the ideas. Because no matter how well you facilitate the meeting, if you don't give people time to think individually and actually get their own ideas in order, there's a real risk of groupthink occurring, which is essentially we're all prone to cognitive biases, and so the first idea that's put forward can sometimes anchor the thinking of a group, and that can lead then to not considering things that would have been considered if the group hadn't anchored on one set of ideas or one set of problems too early. And there are some very famous examples of where groupthink led to really quite catastrophic consequences. Probably the most famous one is the Challenger shuttle disaster. So the first tool I'm going to briefly talk about are checklists. And these are often used in incident investigation, especially infection control. And when I was working on putting this talk together, I downloaded the MRSA and CDIF checklists from the website of my trust to just look through. Essentially, they're structured lists, and they try to ensure that all possible contributory factors are being considered as to whether they could have played a part in the problem. Here's a checklist on root cause analysis investigation that I downloaded from the website of the National Patient Safety Organisation. I've put the link at the bottom, and it goes on for about 4 pages identifying things that should be ticked off as whether they were actually important in the particular case involved. This is usually a patient safety issue. The checklists really need to be designed for the particular problem that you're dealing with. And some of the problems, like say a patient safety problem, are easily have checklists designed as this one. If we move from checklists on to fishbone diagrams, and we used those in the last workshop, and they can either be called fishbone diagrams, Ishikawa diagrams, or cause and effect diagrams. And they used to identify the potential causes of a certain event, and the causes are grouped into major categories. The classic 6 categories, so-called the 6 M's, originated in manufacturing industries. So they start with machine, that's the technology, method, the processes involved, the material, which in pathology could well be the consumables or even information, the manpower, the way the people interact with the process, measurement, which may be inspection, or it may also include some of the management aspects, and then mother nature or environment. But as you can see from this template here, you can change the names of these just to make them more accessible to your particular team without really losing the spirit. So providing you've got a template that covers all the major areas, it doesn't particularly matter what you call the limbs. It's called fishbone because at the head we have the problem, the effect, we have the spine, and off the spine come the bones of the diagram to each category. So what we'll do is we'll write in a box here a primary cause that might be associated with people. That could be perhaps insufficient training or somebody who's not had a proper induction. You could then have a secondary cause, and that may be something like a poor SOP for training people on. And really get the group to work through all these using their knowledge from what they've learned at the Gemba to try and populate this. As I said, bringing their individual ideas to the table. One technique that's often used in Japanese industry, it's a particular cultural thing to try and make sure that all voices are heard, is when facilitating a meeting to ask the most junior person at the meeting their views first, and then work backwards to the most senior person in the meeting, because the risk is if the most senior person speaks, that again can anchor the discussion in an area that's not going to help really finding out what the root causes are. The next tool, again, which we covered in the workshops earlier, was the 5 whys. Now that's really a very simple tool. We start with the presenting problem and then ask why this occurred and repeat until the root cause is identified, which is usually no more than 5 whys. Important thing to remember is that what we want to try and do is use information from the Gemba to answer those questions rather than just pure speculation. So we want to try and root these in reality. So if we go through the chain that we had earlier, the 5 whys, the machine malfunctioned. Why did it malfunction? Because it overheated. Why did it overheat? Because there was a low coolant level. Why was the low coolant level? Because the coolant was leaking. And you could say, well, why was this allowed to happen? Because there wasn't a routine maintenance schedule or something like that. And that might be the root cause, the lack of a proper maintenance schedule for the equipment. One of the criticisms that have been raised about using fishbone diagrams is that they're fairly general about causality. And when we talk about causality, there are essentially 2 different types of causal events. We've got necessary causal events, and these must be present for the effect to occur. So for the machine to overheat, the coolant level had to fall. A sufficient causal event means that the effect must happen if this causal event occurs. And not all necessary causal events are sufficient to cause the problem. You may have multiple root causes that all work together to be sufficient. So when trying to think about it, it's useful to reverse the logic and work backwards. So with the example I gave earlier, the coolant level was low because the coolant leaked. The equipment overheated because the coolant level was low. The equipment failed because the equipment overheated. So you have got a logical sequence that one thing will lead to another. And if you test your 5 whys going back the other way, that will enable you to give some sense of it does all make sense. But it's important to remember there can be multiple root causes. And I want to look at two different examples of this. The first one is something you've probably come across before in looking at incident investigation, which is the Swiss cheese model, that often there has to be a flaw in several parts of the process for a problem to occur that actually causes harm. And all those problems have to line up. All these causes are necessary for the problem to lead to harm, but none is sufficient on its own. It's also important to remember that there are other causes that could be sufficient if the wholes lined up to cause the same sequence of events sometimes. So when doing the investigation, if you want to really nail down the problem and stop it occurring completely, it might be worthwhile looking forward and saying what are the other things that could cause a problem in that part of the process that could lead to this Swiss cheese effect. The other way that multiple root causes can happen is looking at something like this. If we have a service that's meeting customer demand, it's necessary to have sufficient trained staff available to work in a standard process that is effective, and the SOP does need to be followed and the equipment's working. So all these things are necessary for the service to meet customer demand. You may need more of these to overcome deficits in them. But if the service fails to meet customer demand, a failure in any one of those could be sufficient to cause the problem to occur. Right, the final tool I want to talk about is Pareto analysis, and that comes from an Italian economist called Pareto, Pareto's principle is summarized the 80-20 rule, and the axiom is 80% of the effects come from 20% of the causes. And what it's useful for is to identify and focus on the vital few. So which problems are most common and which root causes result in most problems. So I've put together using an Excel template that you can download from the webinar. And imagine that we've got a laboratory that's serving an A&E and 7 wards and outpatients. And there are defects that occur. And there may be specimen labeling defects. Hemolysis doesn't really matter. But you do an audit, you collect data over a period, and you find this pattern. By putting into a Pareto chart, you can have a histogram in which they are ranked in order. So adding all these up together comes to 100%. And the first 3 causes of this account for 86% of the total defects. So what that does really is give us a starting point to say, if we really want to make a big difference, we start with A&E, and then we move to Ward 1 and Ward 2. You could equally have looked at, well, what days of the week does it occur on? Is this a problem that's just occurring at A&E at the weekend, or is it scattered throughout the week? So you can use it to examine data in several ways like that. So that's the use of some of these tools, a fairly whistle-stop tour, I'm afraid, for root cause analysis. But there are other uses. And one technique described by a chap called Gary Klein is what he calls a pre-mortem examination, which is when you're making a change or embarking on a big project, is to have a brainstorming session in advance. Because typically what happens when projects fail is people have a post-mortem afterwards and try to find the reasons why it failed. So a pre-mortem examination is using the kind of approach we've described to say, okay, if in 12 months or 2 years' time this project has not delivered, what could the causes be? And to really to brainstorm through those, and then using something like Pareto to work out, well, what are the major ones we need to actually try and anticipate in advance, and have we got sufficient mitigation for those causes in our plan already? And then risk assessment uses although it's different, uses some of these techniques as well. It's quite useful to brainstorm like this.
Thank you for attending the webinar. As I promised earlier, here are the links to the websites where you can download free Excel templates for fishbone diagrams and Pareto charts.